Hello friends, this is Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University, and this session is about determinants and introduction. In the past sessions, we had only discussed about the theoretical aspects, that is about the practical and the theoretical relevance of the topics which are delivered in this course, be it sequences, series, or determinants, or matrices, or vectors, or three-dimensional geometry. Now we are going to take up each and every topic, and we are going to let you understand how to apply the understanding of each and every concept of the mathematics, and how to solve the problems. To begin with, in this session we are going to start with determinants. Now without wasting the time, let's come up to the objectives of this session. So far as the session objectives are concerned, in this session we are going to define the term determinant, evaluate determinants of order 2 and 3, and understand the properties of the determinants. Now, what are determinants? In order to define it formally, determinants are actually the numerical values associated with the square matrices. That is the matrices with same number of rows and columns. Now, those who are from the very elementary level should be confused that what do we mean by the rows and columns. Now, say determinant. Now, this parallel line actually is the representation of the determinant, as you can see it over here. Now, in this we are having these represent the rows, and the vertical lines represent the columns. So, if there are two rows and two columns, that means the determinant is of order 2. So, order is equal to 2 if there are two rows and two columns. That means determinants are square matrix. Square means where the number of rows is equal to number of columns. So, in this picture, in this example, the determinant is of order n is equal to 2 because there are two rows and two columns. So, that means n is equal to 2 everywhere. You can find that this is a determinant of order 2. Now, how A1, B1 and A2, B2 are available in this determinant? In order to understand this, the determinants are actually used to solve the system of linear equation. Say there are two linear equation A1x b plus b1 equal to 0 and A2x plus b2 equal to 0. Then this can be satisfied by the value of x, which is equal to this. You might be surprised that how this value turns up. So, in order to understand this, how this value turns up, we need to understand how to evaluate a determinant, how to solve a determinant. In order to solve a determinant, we are supposed to perform the multiplication of the terms which are available across the diagonal of the determinant. Likewise, over here, in this case, say A1, B1, A2, B2. See this expression, A1, B1, A2, B2. Now, in this expression, when we are multiplying B2 by A1 and A2 by B1, so we will be getting the solution is B2A1 minus A2B1. So, B2A1, that is B2 into A1 minus A2 into B1 minus A2 into B1. Now, this should be equal to 0. Then it is the solution of the expression of the linear equation A1x plus B1 equal to 0 and A2x plus B2 equal to 0. You need not to worry about this thing. You will be practicing it again and again. But in order to understand this, let's again explain that how we arrived at this determinant. To understand this, let's see, we are having two equation A1x plus B1 equal to 0, A2x plus B2 equal to 0. Now, if we see the terms of this two equation and we just write the coefficient, in the first equation A1 is there, then B1 is there, then A2 is there, then B2 is there. So, this forms the determinant A1, A2, B1, B2 multiplied by x is equal to 0. So, this is actually This is a system of linear equation, and this system of linear equation is now represented in the form of the determinants. So now we can solve this determinant, and how this determinant is to be solved? We multiply B2 by A1 and A2 by B1. That is B2 into A1 minus A2 into B1. So B2 into A1 minus A2 into B1 equal to 0 will be giving you the value of x. So over here, when we are giving a system of equation a1x plus b1 equal to 0 and a2x plus b2 equal to 0, satisfied by same value of x, then this is equal to true. So we will be understanding these concepts in details with the help of examples. This is just a beginning of the journey. So we learned that order of determinant is 2. That means there are 2 number of rows. Order of the determinant is 2. That means there are 2 number of rows and 2 number of columns. So these two, this is a row. There are 2 rows and there are 2 columns. So this is determinant of order 2. Now, what are A1, B1 and A2, B2? Surprisingly, you will be learning that these are the complex numbers. And we will be learning complex numbers in our next block, that is algebra 2, wherein after sequence series we are going to learn about complex number. So you should understand that how determinants and complex numbers are interrelated. So A1, A2, B1, B2 are just the complex number. And we also learned that how to solve this determinant A1, A2, B1, B2 is that B2 into A1 minus A2 into B1. So diagonally we need to multiply, and whatever the products available we need to subtract them. So if we again see B2 into A1, B2 into A1, so B2 into A1 minus A2 into B1. So this will be the solution of this determinant. This value will be the result of this determinant. Now the expression is called the determinant of order 2, that is second order, because there are 2 number of rows and 2 number of columns. Now let's solve some examples. Over here in the example number A, we are given a determinant 3, 5, minus 2, minus 6. Now, what is the order of this determinant? Because there are 2 rows and 2 columns, the order of the determinant is 2. It is a determinant of order 2. Now let's solve it. 3, 5, minus 2, 6. So this into this minus this into this. So 6 into 3 minus 2 into 5. So 6 into 3 is 18 minus 2 into 5 is minus 10. So that is 18 plus 10 equal to 28. So this is the answer for the solution of this determinant of order 2. I hope you understand how to solve this. Now let's solve some more problems. Likewise over here, the problem number B is we are given a determinant 1 minus t square upon 1 plus t square, 2t upon 1 plus t square, minus 2t upon 1 plus t square, 1 minus t square upon 1 plus t square. So these are equations. So this is one equation, this is another equation. These are independent expressions. Now we can directly say that this is say A1, this is say B1, this is say A2, and this is say B2. Now again what we are supposed to do? A1 in B2 A1 minus A2 B1. Remember, B2 A1 minus A2 B1 is to be solved. So over here B2 is 1 minus t square upon 1 plus t square, and A1 is also 1 minus t square upon 1 plus t square minus of A2 B1. So what is A2? A2 is minus 2t upon 1 plus t square into B1 is 2t upon 1 plus t square. So I think we are on the lines A2 B1 minus B2 A1. Now we are going to solve these expressions and identify that what could be the possible solution. Now 1 minus t square into 1 minus t square, what could be this? This should be equal to 1 minus t square का whole square upon 1 plus t square. So 1 plus t square, that means whole square of this. Now this is the first term, 1 minus t square of 1 plus t square whole square plus. Now minus is outside over here and minus is here. So minus into minus is plus, so that's why the sign is plus. Now 2t into 2t, that is 2 into 2, 4t square upon 1 plus t square into 1 plus t square. So this should be 1 plus t square whole square. So I hope you got the expression 1 minus t square upon 1 plus t square, 1 minus t square upon 1 plus t square whole square plus 4t square upon 1 plus 4t square, 1 plus t square whole square. So we derived this expression. I hope you are able to understand how to solve the determinants. Now, so we reach to the expression this. Now we need to solve this expression. So that means we got the expression 1 minus t square upon 1 plus t square whole square, this expression plus 4t square upon 1 plus t square whole square. So that means this is equal to 1 minus t square whole square upon 1 plus t square whole square plus 4t square upon 1 plus t square whole square. Now if we take 1 plus t square upon whole square as a common, so we will get 1 plus t square whole square, and we solve this expression 1 minus t square whole square plus 4t square. Now we all know that a minus b square is equal to a minus b square plus 4ab is equal to a plus b square, because a minus b square is a minus b square is equal to a square plus b square minus 2ab, and a plus b square is equal to a square plus b square plus 2ab. So a minus b whole square plus 4ab will be equal to a square plus b square minus 2ab plus 4ab. So this is equal to a square plus b square plus 2ab, and which is nothing but a plus b whole square plus 4t square. So you can say that this expression is nothing but 1 plus t square. So what you got is this expression is again 1 plus t whole square. So this is 1 plus t whole square upon 1 plus t whole square. So this cancels with this and the answer will be equal to 1. So this expression solves to the value 1. I hope you are able to understand what is the procedure to solve a determinant of order 2. We solve the determinant for the constants and we also solve the determinants for the equations. So that means equations can also be the components for the determinants, and what determinants are actually the values are representing the complex numbers. Now let's understand the determinants of order 3. Now over here we are having three equations, a11x plus a12y plus a13z is equal to b1, a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. Now again applying the same understanding, if I resolve this system of equation, then we can say A11, A21, A31, A12, A22, A32, A13, A23, A33 into X, Y, Z is equal to B1, B2, B3. Now this is determinant of order 3. This is determinant of order 3. You can just map it with this A11, A21. So A11 is this value, A21 is this value, A31 is this value. Coefficients of x, y and z. A12 is coefficient of y, A22 is coefficient of y in second equation, A32 is coefficient of y in third equation, A13 is coefficient of z in first equation, A23 is coefficient of z in second equation, A33 is the coefficient of z in third equation. So this is because there are 3 number of rows and 3 number of columns, that's why the order of the determinant is 3. This is determinant of order 3. So it has got 3 rows and 3 columns and all are complex numbers. Now again we need to understand how to solve the determinant of order 3. Likewise, when we learn that if there are if the determinant is of order 2, then we apply the technique this into this, the B2A1 minus A2B1, B2A1 minus A2B1. Now we are going to apply the understanding to solve the determinant of order 3. So in order to solve the determinant of order 3, we need to understand firstly that the polarity of the sign varies in the manner, say first is positive, then negative, then positive, then negative, then positive, then negative, then positive, then negative, then positive. Why I am saying writing positive and negative, you will understand in a moment. Now, in order to solve a determinant of order 3, firstly we take up first row and first column. Element of first row and first column is this. So, first row and first column. So, what is this element? This is A11. Now, what are the remaining elements? The remaining elements are forming a determinant of order 2. So, this is determinant of order 2. A22, A23, A32, A33. Now, what is the polarity of the sign is positive. So, that's why this is positive. Now, next we take first row and second column. What is first row, second column? Is A1, 2. Now, after removing first row and second column, what are the elements of the determinant? The elements of the determinants are A21, A23, A31, A33. And what is the polarity of the sign? Negative. So that's why it is negative. Again, we take the third element, that is first row and third column. What is that element? A13. After that, the determinant of order 2 is A21, A22, A31, A32. And the polarity of the sign is plus, minus, plus. So again the sign should be positive. So you can see that the expression this is actually this. So this is positive, positive, this is negative, this is negative, this is positive, this is positive. This is A11, this is A12, this is A13. This is A22, A22, A23, A23, A32, A32, A33, A33. So this actually is this expression. So I hope you understand how you solve this determinant to this expression. Now all these are determinants of order 2 and you simply apply the understanding of solving the determinants of order 2. How you solve the determinants of order 2? In order to solve the determinants of order 2, you should apply the understanding that if the determinant is a1, b1, a2, b2, then to solve it diagonally you multiply and subtract, that is b2a1 minus a2b1. So this into this minus this into this. So a22 into a33 minus a32 into a23. Similarly, this into this minus this into this. So a33 into a21 minus a13 into a23. Similarly, a32 into a21 minus a31 into a22. So this is the final solution of the determinant of order 3. This is determinant of order 3. I hope you are able to understand how to solve the determinants of order 3. Now we will apply the understanding of solving the determinants of order 3 with the help of some examples. Now over here there is a question, there is an example that evaluate the following determinant by expanding the first row. Okay, let's expand the first row. So intersection happens at A. So first element should be A, and the remaining determinant of order 2 is this. So determinant is of B0, 0, C. Since polarity begins with plus, minus, plus, so this sign should be positive. Thereafter, because we are going to expand it across first row, so second element should be first row and second column. So plus, minus, plus. So that means second element should be minus, and the intersection happens at 0. So it should be 0. After that, the elements of determinants of order 2 are 0, 1, 0, C. Thereafter, expanding the row again to the first row. So first row and third column intersection happens at 1, and the polarity should be plus, minus, plus. So third element is plus, sign of third expression is plus, and intersection happens at 1. So our value should be 1. Thereafter, the determinant of order 2 is 0, 1, B, 0. I hope you got this expression. Now we expand these expressions. This is B into C minus 0. Since this expression is multiplied by 0, so entire value should be 0. And this expression should be 1 into 0 minus B. So 0 minus B into 1 plus 0 minus A into BC minus 0. So by solving this expression, by solving this entire expression, we will get A, B, C minus B. So I hope you learned that how to solve the determinant of order 3. Now applying the understanding of solving the determinant of order 3, you can solve the problem this: 1a bc, 1b ca, 1c ab. So this is a determinant of order 3. Again, expanding the expression as told, you will get this expression. Now after solving this expression, you will get the final solution as ab square minus a square b plus bc square minus b square c plus a square c minus ac square. So this is the solution for determinant of order 3. Now again there is an important concept of minors and cofactors, and before studying some of the properties of the determinants, we introduced you the concept of the minors and cofactors. Now what are minors? Now minors say if delta is the determinant, then minor Mij, now we represent minors by expression Mij, where I represent rows and j represent column of an element Aij is determinant obtained by deleting ith row and jth column of the determinant delta. So if I say, so that means Mij is the minor of the element Aij. So if I is the determinant obtained by deleting ith row and jth column of the determinant. So if I say M21, so M21 second row and first column. So what are the elements remaining? These two and these two. So that means A12, A13, A32, A33. The determinants of the remaining elements A12, A13, A32, A33 will comprise the minor A21. Similarly, if you want to say that, what could be the minor of A32? Now A32, so that means minor M32, that means removing this element. What are the available elements? This. So A11, A11, A13, A21 and A23. The determinant of these elements comprises the minor A32. You can similarly find M11, M22, M33 or any other. So for the sake, if we want to find M11, then what should be M11? Now, then M11 should be remaining elements after this, that is equal to A22, A23, A32, A33. So this will be the minor for M11. That is, if element, again see the definition. If delta is the determinant, so delta is the determinant, then Mij of the element Aij is the determinant obtained by deleting ith row and the jth column of the determinant delta. So over here what we had done, we had removed ith row and jth column, and whatever elements are remaining are the minor for A11. So M11 is the minor of A11. Similarly, as we had solved for determinant of order 2 and order 3, similarly we can find the minors. Likewise, say delta is A11, A12, A13, A21, A22, A33, A31, A32, A33. So determinant delta will be the same expression as discussed over here. This is the expression. We solved this and we are getting this expression. So what are these? A22, A23, A22, A23. This is in fact M11. So that means this is M11. A21. So that means we need to let you understand that what is the relevance of calculating the minors. So whatever determinants, these determinants of order 2, we resolve the determinant of order 3 into determinants of order 2, and these determinants of order 2 are in fact the minors. So this is minor M12, this is minor M13. So multiplying minor with the element which is removed. What was the definition? Element Mij of the element Aij is the determinant obtained by deleting ith row and jth column of the determinant delta. So after removing A11 first row and first column, this is M11. So that means A11 multiplied by M11 is the first element of the solution of the determinant. Contributing to the solution of determinant A13 into minor of A13 is again contributing to the solution of the determinant. So the overall solution of the determinant is A11 into M11 minus A12 into M12 plus A13 into M13. Similarly, we can get the solution of the determinant if we expand the determinant across second row and third row. Likewise over here, if we want to understand, we also learned that the polarity of the sign varies from positive to negative to positive to negative to positive, positive, negative, positive. So if we expand it across the second row, then the sign starts with negative because the polarity is negative. So first element of the second row is A21. So first element of the second row is A21. After removing A21, what are the elements which are remaining? This is A12, A13, A32, A33. So this is nothing but minor of M21. So that means minus A21 into M21 plus A22 into M22 minus A23 into M23 is again the solution of the determinant. The sign variation of sign is negative. So negative, positive, here is positive, and negative, and here is negative. So I hope you learned that we can calculate the minors by expanding across several rules separately. Similarly, we can get the solution of the determinant if we expand across the row number 3. Now, what are cofactors? So far as the definition of the cofactors is concerned, the cofactor Cij of the element Aij in the determinant is defined by minus 1 to the power I plus j into minor, where Mij is the minor of the element Aij. So Cij is nothing but minus 1 to the power I plus j into Mij. So if I say C11, then equal to minus 1 of 1 plus 1 into M11. So what could be M11? So M11 will be equal to determinant A22, A23, A32, A33 into minus 1 to the power 2, because 1 plus 1 is 2, is equal to C11. That is equal to similarly A22, A23, A32, A33. So you can say that because over there in the last session, in the last slide, you had seen that there is a change in sign. There is a change in sign. Plus, minus, plus, minus, plus. So in order to maintain the consistency of the sign, minus 1 to the power I plus j, the first element is positive. Now, if we take C12, say, so if we want to take C12 will be equal to minus 1 to the power 1 plus 2 into M12, that is minus 1 into M12 will be equal to A21, A23, A31, A33, that is equal to minus of A21, A23, A31, A33, that is minus of M12. Now looking into this expression, minus of M12. So minus of M12 minus is equal to C12. So that means it will be, if I substitute minus of M12 over here in this equation, then it will be M11, A11, M11 plus A12, C12. So that means we had removed the negative sign. So cofactors are used actually to maintain the sign. There should not be any change in polarity of the sign. So determinant delta, if we expand it across first row, will be equal to A11 C11 plus A12 C12 plus A13 C13. Same delta will be equal to if we expand it across second row. Same delta will be equal to if we expand across the third row. So the entire logic was to maintain the consistency of the sign. So minors and cofactors are interrelated. What are cofactors then? Cofactors are expressions say Cij is equal to minus 1 to the power I plus j into Mij. And what for they are required? They are required to maintain the polarity of the sign. In the earlier section, when we were discussing about these expressions, there we observed that there is a change in the polarity of the sign. Over here, first positive, then negative, then positive. So to remove this fluctuation in sign, the concept of cofactors come into the picture. And we got an expression. This expression is equal to delta equal to A11 C11 plus A12 C12 plus A13 C13. So both are equal, both are same. Over here we are talking about minors, over here we are talking about cofactors. I hope you understand that what is the relevance of minors and cofactors when we are evaluating the determinants. So let's move ahead. Write down the minors. Let's solve some example. Write down the minors and cofactors for each element. So over here, say a determinant of order 2 is given, 3, 2, minus 1, 5. So if I take M11, so M11, after this only 5 is remaining. M21 minus 1 is remaining. And after this, if I say M12, 1, 2, after this only 2 is remaining, and M1, M22, M22, so after this only 3 is remaining. So we got these as the minors. Now if we calculate the cofactors, then Cij is equal to minus 1 to the power I plus j Mij. So C11 will be equal to minus 1 to the power 1 plus 1 into M11, that is equal to 5. C12 will be equal to minus 1 to the power 1 plus 2 into M12. M12 is 2. So that means minus 2. C21 will be equal to minus 1 to the power 2 plus 1 into M21. And M21 is nothing but minus 1. So minus 1 into minus 1, that is equal to 1. And C22 will be equal to minus 1 to the power 2 plus 2 into M22. Now what is M22 is 3, so this is equal to 3. So we got the cofactors, we got the minors. I hope you understand that how to compute the minors and cofactors of the determinants. Now let's extend our discussion to other details. We are having some of the properties of the determinants, and the properties are as follows. There is a reflection property. The determinant remains unaltered if the rows are changed into columns and the columns are changed into rows. So if I say we are having A1, B1, A2, B2, then the value of this determinant will be equal to delta. So same value will be there, that is delta will be same if A1, B1 and A2, B2. That means rows are changed into column, rows are changed into columns, rows are changed into columns, or columns are changed into rows. You mean to directly say that columns are changed into rows. So if I say vice versa, it is the reflection property. All zero property. If all the elements of a row column are 0, then the determinant is 0. So that means if all the elements are 0, then this into this minus this into this, that is 0 into 0 minus 0 into 0 is equal to 0. This is self-explanatory. This is all zero property. Next, we are having a proportionality repetition property, which says that if the elements of a row column are proportional, identical to the elements of some other row or column, then the determinant is 0. If I want to say A1 and B1, and say k times of A1 and k times of B1, then the determinant is 0, because if the elements of the row or column are proportional, identical to the elements of some other rows, so this element is proportional to this element proportional to this, so this result will be equal to 0. I hope you understand these three properties. Now we extend our discussion to further more properties, that is the switching property, which says that if we interchange any rows, columns of the determinant, the changes the sign. That means if we interchange the rows and columns, then the sign of the determinant changes. We already learned that if we are having a determinant, we are having, say, polarity is like this: plus minus plus minus plus minus plus minus plus. So if we interchange, then the if we interchange any two rows or columns, then the polarity of the sign changes. So this is if we interchange, say, A1 B1 C1, A2 B2 C2, A3 B3 C3, then if we interchange, say, these two rows or these two rows or these two columns or these two columns, or then then the sign will change. We will go into further more details when we will be solving the numerical examples uh, in the upcoming sessions and the slides. The next important property is scalar multiple property, which says that if all the elements of a row column of a determinant are multiplied by a non-zero constant, the determinant gets multiplied by the same constant. So friends, in this session, we learned about the determinants of order 2 and order 3, how to solve the determinants of order 2 and order 3. Apart from this, we understand that what are minors and cofactors, and how to calculate the minors and cofactors. Also, we had learned how minors and cofactors plays vital role in the evaluation of a determinant. I hope after going through this session, you will be able to solve the problems for minors, cofactors, evaluation of the determinants of order 2 and order 3. And I hope you enjoyed this session. Thank you very much.